In this video, I will explain what is a binary number and how do we convert between a binary number to decimal number and how do we convert from decimal number to binary. And I will also explain what is a hexadecimal number. First of all, what is decimal number? So decimal number is the number system that we use in day-to-day life. For example, 100 is 100, 21 is 2 and 1, and 13 is 1 and 3. So we use that number to determine how many objects we have. So that means we are counting objects. So to represent a decimal number, we will put together a sequence of different digits, and the digits can be between 1, 2, 3, up to 9. So we can use 10 different digits, put them in a sequence, and that will create a decimal number. And binary number is something similar, but instead of using 10 digits, we are only using 2 digits, which is 0 and 1. So any number system, whether it is binary system or decimal system, it is used to calculate how many objects we have. For example, if I have here I have 1 pen, so this will be 1. If I have 2 pen, it will be 2. But if I have three pen, then in decimal number it will be 3. But in binary it will be 1, 0. Now to explain that further, let's say this is us 1,000 years ago, where we haven't discovered what is a binary number, or even we haven't discovered what is a decimal number. We don't know anything. Let's say we want to count how many apples we have, so that one person can talk to another person, how many apples they have. Okay, let's say this is 1 apple, and this is us 1,000 years ago. And 1,000 years ago, we count everything in base 1, which means we can use 1 stick to represent 1 apple. So 2 stick will represent 2 apple, and 3 stick put together will be 3 apples. Now, if I calculate in base 5, how do I use that? I will use symbol to do that. Okay, so let's say this is 1. I use 1 stick. Remember that this is base 5. Okay, this is 1. I put 1 stick. This is 2. This is 2 objects. Let's say this is 2 apples. Then I put 2 stick together. This is 3 stick together. This is 4 stick together. And this is 5. So instead of putting another stick, I will just put the last one across the 4 different sticks. And then because this is base 5, that means if I want to go from 5 to 6, I will need to repeat the patterns. So the patterns will be 4 different sticks with a dash, which represent number 5. And then I will use the symbol for 1, which is over here. And this would be 6. And this one, how many objects are there? It will be 5 plus 5, because this patterns, this symbol, represent 5 objects, whereas this symbol also represent 5 objects. So this whole symbol will represent 10 objects. Now let's say I count in base 4 using symbol. This is 1 stick, 1 matchstick. This is 1, and this is 2. So to represent two objects, I will put 1 stick in vertical, another stick in horizontal. So this would be 2, and this would be 3. And then this would be 4, because it has 4 sticks in a symbol, in a square symbol. So because this is base 4, how would I go from 4 to 5? I will need to repeat the patterns. So I will keep the square, which represent number 4, represent 4 objects, and then use another stick so that this one would be 4 plus 1, which is 5 objects. So in this example, I talk about base 1. I talk about base 1, base 5, and base 4. And what I want you to keep in mind is that this one is used to count how many objects we have. And if we want to go from 5 to 6 in a base 5, we need to repeat the patterns. Okay, this is base 1, 5, and 4. Now let's go to base 10, which is the number system that we are normally using in day-to-day life. And this one is called decimal. Okay, let's count from the beginning. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now if I want to increase by 1, what do I do? Okay, remember the previous example that we have? Because this one is base 10. If you want to add 1 to 9, that means you have to repeat the patterns, which means you have to use another digit because we are out of digits. We don't have any digits after 9. So we need to repeat the patterns, just like the previous example that we have. Okay, so we need one more digit. Okay, so the way we do that is that we will use one more digit, start from 1 in here, and then we keep the same patterns, which is 0, 1, 2, 3, 4, and just like that. So it's similar to base 1 and base 4 and base 5 in the previous slide that I have. In here, if you want to increase by 1, you use the digit that you have before, put it here, and then you repeat the patterns from 0 to 9. That's how you count it. Okay, so let's say from 99, if I want to increase by 1, how do I do that? Because I'm running out of digits, I will need to repeat the patterns by adding the digits 1, make it 3 digits, and then repeat the pattern 0, 0, 0, 1. Okay, now we come to binary, which is base number 2. How do we do that? So base 2, we have 2 digits, which is 0 and 1. Now, if we want to increase by 1, how do we do that? We are running out of digits. Okay, what do we do in this case? We don't have any more digits. So we repeat the patterns. We use another digit. We need one more digit. And then we repeat the patterns. Okay, so we're gonna use 1. And then we repeat the pattern, 0 and 1. So this is 0, this is 0 apple, this is 1 apple. This would be 2 apple, and this would be 3 apple. Why is that? Because we are counting. Remember, we are counting. We are adding one more objects every time we repeat the patterns. So this is 0, 1, this would be 2, and this would be 3. So just remember, 1, 0 will be 2. Okay, so this is 0, 1, 2, 3. How do I represent number 4? Okay, to do that, I will need to repeat the patterns. I will need to use another digits, which is 1. And then I repeat the pattern 0, 0, 0, 1, 1, 0, 1, 1. So let's count it again. 0 is 0, 0 apple, 1 apple, 2 apple, 3 apple. This is 4 apple. This is 5 apple. This is 6 apple. And this is 7 apple. And this is binary number. This 0, 1, 0, 1, 1, 1, 1, 0, 0, or 1, 1, 1. They are called binary number. Okay, now that we have this pattern, let's have a look at the table that I have prepared. This is decimal in base 10, and this would be the corresponding number in binary system, which is base number 2. Okay, so in here I use 4 digits to represent the number. Okay, so 0 would be 0, 1 would be 0, 0, 0, 1, 2 would be 1, 0, and 3 would be 1, 1. And to go from 3 to 4, because we are running out of digits, we will use another digit called 1, and then we put 2, 0 underneath. And then we repeat the patterns up until 15. Okay, now let's break down a decimal number so that we will understand how do we convert between decimal to binary and vice versa. Okay, let's say this is 1998. This is our decimal number. I will break it down into 4 different digits. Okay, so 8991, 8991. Okay, these are called the digits. These are called the number. And these are called the digits of the number. Okay, I will write it in 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. Okay, what is the 10? The 10 is the base, and 0, 1, 2, 3 are called positional index. Why it's called positional index is because the index of the first digit is 0, so we count starting from 0. The index of the digit 9 would be 1. And the index, the position of the second digit 9 would be 2. And the position of number 1 is 3. And the number 10 here is called base 10. Okay, now we multiply and add them up. Okay, so we take 8 and then we multiply by 10 to the power of 0. We take the base, we take it to the power of 0. Okay, so 8 times 10 to the power of 0 plus 9 times 10 to the power of 1 plus 9 times 10 to the power of 2 plus 1 times 10 to the power of 3. And then if you add these up, you will get 1998. Keep in mind that 10 to the power of 0 would be 1. Anything to the power of 0 would be 1. And then, of course, 10 to the power of 2 would be 100, and this is 1,000. Okay, now I'm going to repeat this for a binary number. Okay, let's say I want to convert from binary to decimal. How would I do that? Let's say I have a binary number in here, which is 1101. The number 2 here, the number 2 you see in here, is to tell you that this one is a binary number. Okay, so I will write down the digits, just like what I've done before. So these things are called the digits, and then I write from right to left, 1011, 1011. And then I will write 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. This one is base 2, because this is in binary, which is base 2, because we have 2 digits. Whereas the other one, we use 10 different digits from 0 to 9. That's why it's base 10. This one is base 2. And again, this one are called positional index. Now we multiply and add them up, just like what we have done before. 1 times 2 to the power of 0, this thing. And then plus 0, take the digits, times 2 to the power of 1. Next one, 1 times 2 to the power of 2. Okay, if I add them up, 2 to the power of 0 is 1. So this is 1. 0, of course, is 0. 2 to the power of 2 would be 2 times 2, which is 4. And 2 to the power of 3 would be 2 times 2 times 2, which is 8. And if I add them up, I will get 13. So 13 is the decimal number. Or you can say we have 13 apples in this case. Or you can say 1101 is a binary number that represents 13 different objects. What you can write is you can write 1101 and then put the number 2 smaller underneath, equal 13, put the 10 underneath. These 2 and 10 are called subscript, or we can call it the base of the number. This is base 2, this is base 10. And base 2 are called binary, base 10 are called decimal. Another way you can write this is you can write OB, 0B, 1101 equals 13. Okay, this OB is called the prefix. Prefix means you write before you write a number. These are called prefix. And the prefix for binary is OB. You may ask, why don't we have prefix for 13? It's because the convention is that if we want to represent a decimal number, we do not use any prefix. Okay, now let's go to hexadecimal number. So hexadecimal number is similar concept, but instead of using base 2 or base 2 or base 10, hexadecimal number is in base 16. And if you want to understand why do we have base 2 and base 16, it's not very intuitive. You need to keep watching the lectures, and you need to come to my live lectures where I explain everything. Okay, now let's go through this example real quick. Counting in decimal. This one is counting in decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 17, 25, 26. Okay, now if I want to count in hexadecimal number, then this is how I'm gonna count it. So I will start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, similar to the decimal number. Now here comes the interesting part. Because we use this is hexadecimal number, so we have 16 different digits, which means we need to use a distinct symbol or digit to represent the next number after 9. We don't have to repeat the same pattern because we still have more digits. This is base 16. We only run out of digits when we come to 16. Okay, so the convention for number 10 in hexadecimal number is the letter A. So after 9, it will be letter A, letter B, letter C, D, E, F. So F would be 15. And how do I go from 15 to 16? Remember all the examples that we have done before? What you have to do is you have to repeat the pattern and you need to use another digit. So from 15 to 16, I will go from F to 1, 0. Why 1, 0? Because I take this 1 and then I use 0. So this is very confusing, I know. 16 in decimal number, 16 apple, 16 objects, is represented as 10 in hexadecimal number. And then after 10 will be 11, 12, 19, 19 is 25. And to go from 25 to 26, how do I do that? How do I go from 19 to the next number? Okay, I just increase it by 1. Okay, so what is the digit after 9? After 9 is the letter A. 9 go to A. So from 19, 1, 9, it will be 1A. Okay, why do we use hex? Hex is an abbreviation for binary number. What is abbreviation? Abbreviation means short form. Okay, so 1 hex digit represents 4 bits, 16 distinct values, 2 hex, blah, blah, blah. If you want to understand this more, please watch my lecture. In this video, I only cover how do you convert from binary to decimal number. But if you want to understand how and why do we use hex, why do we use binary, then I will explain more in the lecture. Okay, so now if you want to practice converting between a binary number to decimal number and from decimal number to binary number, you can rewatch the video where I explain how you convert from binary to decimal, and then you can do some other example. You can just come up with a random binary number by just putting 0 and 1 together, and then you can go to Google and then ask them to convert and then do your own calculations, and let's see if you can get the same result.